In this lecture, I am going to present what is sway frame and what are the conditions and how to analyze the sway frame by slope deflection method. Then I would like to solve one problem by slope deflection method. So first coming to the what is sway frame. If the frame is unsymmetrical with respect to geometry or loading or due to both, the sway of the frame takes place. So look at this figure. Here there is present two load. One load is on the horizontal member, another load is at the joint B. So this is A, B, C, D. Due to this load, here the sway of the frame takes place. So this is the example of the non-sway frame. Sway due to horizontal force and unsymmetry. And here you see, so on the span BC, there is present the uniform distributed load, and at the joint B, there is present one horizontal loading. So due to this horizontal loading, here also the sway takes place. Because at the beam level, there is no support, so here the sway of the joint or the vertical member takes place. The sway amount is delta. So here the sway takes place due to horizontal force only, because the UDL is symmetric about the central axis. So only due to this horizontal force the sway of the frame takes place. Then look at this figure. So here the vertical load is present unsymmetrically. So due to this unsymmetrical load, here the sway of the frame takes place. So this is the sway delta amount of this vertical member. Here this is the delta amount of this vertical members. So this is the sway frame due to unsymmetry of loading. So here the sway takes place due to unsymmetry of the geometry. So here the height of the two vertical members are different. So due to this unsymmetry of geometry, the sway of the frame takes place. So the sway takes place, the amount, this is delta and delta. So this is the example of the sway frame due to unsymmetry of geometry. Here the sway takes place due to unsymmetry of the column properties. Here the moment of inertia of AB is I1 and moment of inertia of BC I3 and CD I2. So here the moment of inertia of all the spans are different. Due to this column properties or due to this the different moment of inertia, the sway of the frame takes place. This is the example of the sway due to unsymmetry of column properties. Then coming to how to analyze the frame with sway. Look at this figure. Here this is the example of the sway frame, and this is vertical member AB, this is vertical member CD. Support A is fixed and support D is fixed, and BC, so this is the two joint. At the support A, so due to fixed end, the slope theta A is equal to 0, and at support D, due to fixed end, the slope theta D is equal to 0. Here there are three unknown displacement. So two rotational displacement and one is translation displacement. So two rotational displacement is that is at B and at C, theta B and theta C, and one translation displacement, that is delta. So here these three unknown displacement that you can find out by using the three equilibrium equations. In this problem, you can take one joint equilibrium equation at B and another joint equilibrium equation at C. That is the sum of the moment at B is equal to 0 and sum of the moment at C is equal to 0. That is MBA plus MBC is equal to 0 and MCB plus MCD is equal to 0. So there are two equations, but here there are three unknown displacement. You have to take another one equation so that you can find out these three unknown displacements. The third equation that you can find out by taking the horizontal shear in the vertical members. So here that at the joint B, summation of moment B is equal to 0, MBA plus MBC is equal to 0. At joint C, summation of moment at C is equal to 0, MCB plus MCD is equal to 0. And the third equation will be obtained from the horizontal shear in the vertical members will be equal and opposite to the external horizontal forces. What is the horizontal reaction at A and horizontal reaction at D? So HA plus SD, that is equal to P. So this is the horizontal force P, and here the horizontal reaction at A, HA, and the horizontal reaction at D, SD. So HA plus SD, that is equal to P. So this is the third equation. By using these three equations, you can find out the three unknown displacement: 2 rotational displacement and 1 translation displacement. Here you have to find out the HA and SD, the horizontal shear at A and the horizontal shear at D. So that you can find out by taking the free body diagram of column AB and column CD. So by taking the free body diagram of column AB and column CD, you can find out the horizontal reaction at A and the horizontal reaction at D. That is the horizontal shear at A and horizontal shear at D. So this is the free body diagram of column AB and the column CD. This is A and B, and here a moment you are considering clockwise moment, that is a positive moment MAB, and here this is also clockwise MBA, and the load is present here P, that is at a distance A from the joint B, and here you have to take the horizontal reaction at A, this is HA, and this is you are passing the vertical reaction that is passing through the axis of the beam, so this is cancel each other. Similarly, so the free body diagram of column CD, so here you have to take, this is the moment MDC clockwise positive, and here also MCD, this is clockwise positive, and here the reaction at D, horizontal reaction at D is equal to HD, and the vertical reaction at D and C, this is passing through the axis of beam, so this is equal and opposite, so this is cancelled. Here you have to find out, so what is the horizontal direction at A and what is the horizontal direction at D. Then you can find out the third equations. You have to take for column AB, you have to take the moment about the joint B, and for column CD, you have to take the moment about the joint C. So in AB column, taking moment about B, here you take, this is clockwise and this is clockwise, MAB plus MBA, both are clockwise, and due to this force, so the moment is anti-clockwise, P and P into A, and due to this horizontal direction at A, the moment is anti-clockwise. So this is HA into LAB, the length of the AB is LAB, HA into LAB. So P into A, and this is HA into LAB is equal to MAB plus MBA, and you can find out HA is equal to MAB plus MBA minus P into A divided by LAB. So this is the horizontal direction at A. Similarly, you can find out the horizontal direction at D by taking the moment in column CD, that is about the C point. So here MDC clockwise, MCD is also clockwise, the clockwise moment is equal to anti-clockwise moment. So MDC plus MCD is equal to HD into LCD. HD into LCD is equal to MDC plus MCD. So HD is equal to MDC plus MCD divided by LCD. So this is the horizontal direction at D. After knowing the horizontal direction at D and A, then you can take the horizontal equilibrium equations for the frame, that is HA plus SD plus P is equal to 0. So this is the horizontal direction, and already you know this is the two joint equilibrium equations, and this is the third equation. So by using these three equations, you can find out the three unknowns. If there is no horizontal force, if the horizontal force is not present here, so that case you take the horizontal direction at A and the horizontal direction at D, that is equal to HA is equal to MAB plus MBA divided by LAB, because here the P is equal to 0. Similarly, the horizontal direction at D is equal to MDC plus MCD divided by LCD, because here HA is equal to MAB plus MBA minus P into A by LAB. So because here the horizontal load P is present, so that's why. So you can by using this formula you can find out the horizontal direction at A. But if the horizontal load is not present, so you have to take the P value is equal to 0. So that case HA is equal to MAB plus MBA divided by LAB. Similarly, SD is equal to MDC plus MCD divided by LCD. SD is equal to MDC plus MCD divided by LCD. So this is the two horizontal direction at A and D. So due to the absence of the horizontal loading. Then coming to the example, analyze the frame shown in figure and draw bending moment diagram. So this is the frame. So this is the sway frame due to the unsymmetry of the geometry. So because here the height of the vertical member AB is given 4 meter and height of the vertical member CD is given 6 meter, and also from the properties of the member, so here this is I and this is BC 2I and CD 2I. So here the sway of the frame takes place. So the sway amount here delta and here also delta. Let delta be the sway in the figure. The axial deformation in member BC is assumed negligible, hence both columns sway by same amount. Neglect the axial deformation in member BC, so what is the translation displacement takes place at B? The same translation displacement takes place at C. So delta amount. So both the translation displacement is equal to delta. On the horizontal member BC, so there is present the uniform distributed load of intensity 40 kN by meter and the span length is given 6 meter. In this problem, due to the fixed end at support A, so the slope is 0, theta is equal to 0. Also due to the fixed end at support D, theta D is equal to 0. So here at a joint B, the slope is equal to theta B, and at a joint C, the slope is equal to theta C. And this is the translation displacement. So here there are two rotational displacement at B and C, theta B, theta C, and one translation displacement, that is delta. These three displacement that you can find out by using the three equilibrium equations. So as you know the steps in slope deflection method, so first you have to find out the fixed end moments. As there is no loading on the vertical member AB, the fixed end moment MFAB and MFBA is equal to 0. And on the horizontal member BC, there is present a uniform distributed load of intensity 40 kN by meter. Here MFBC is equal to minus 40 into 6 square by 12 and MFCB is equal to plus 40 into 6 square by 12. And on the vertical member CD, there is no horizontal loading. So here also MFCD is equal to 0 and MFDC is equal to 0. So these are the fixed end moments MFAB, MFBA, MFCD and MFDC 0, and MFBC is equal to minus 40 into 6 square by 12 minus 120 kilonewton meter, and MFCB is equal to plus 120 kilonewton meter. These are the fixed end moments. Then what are the end conditions? So here the end conditions, that is rotation at end A and D, that is theta A, theta D 0 due to fixed end, and rotation at B and C is theta B, theta C, this is unknown, and the lateral displacement of column is delta at beam level. So these three are the displacement that you have to find out, theta B, theta C and delta. Then write down the slope deflection equations. So as you know, the formula MAB is equal to 2 EI by L, 2 theta A plus theta B minus 3 delta by L plus MFAB. Here 2 EK, K is equal to I by L. Here K is equal to moment of inertia by span length. So 2 EK, or you can also write 2 EI by L. Similarly, MBA is equal to 2 EK, 2 theta B plus theta A minus 3 delta by L plus MFBA. So find out MAB, MBA, MBC, MCB, MCD and MDC. As you know, MAB is equal to MFAB plus 2 EI by 4, 2 theta A plus theta B minus 3 delta by 4. But you know theta is equal to 0 and delta you have to find out. So only have to put theta is equal to 0. Then after simplification, MAB is equal to 0.5 EI theta B minus 0.375 EI delta. Then MBA is equal to MFBA plus 2 EI by L, theta A plus 2 theta B minus 3 delta by L. So here also theta is equal to 0 and you have to put 2 theta B and the delta and 2 EI by 4. The span length is given 4 meters, so put, and MBA is equal to EI theta B minus 0.375 EI delta. Then for BC, MBC is equal to MFBC plus 2 EI by L into 2 theta B plus theta C, 2 theta B plus theta C. And here you have to take delta is equal to 0 for horizontal member. So you have to take delta is equal to 0. But here given the moment of inertia is 2I and span length is given 6. So here you have to put 2E minus 120 MFBC plus 2E 2I by 6, 2 theta B plus theta C minus 0. So this is equal to minus 120 plus 1.333 EI theta B plus 0.667 EI theta C. Then MCB is equal to 120 plus 2E 2I by 6 theta B plus 2 theta C minus 0. So this is equal to 120 plus 0.667 EI theta B plus 1.133 EI theta C. Then for vertical member CD, so find out MCD and MDC. MCD is equal to MFCD plus 2 EI by L, 2 theta C plus theta D minus 3 delta by L. So here length is given 6 meter and moment of inertia is given 2I. So 2E into 2I by 6, 2 theta C plus theta D minus 3 delta by L. So here you put the value. So theta D is equal to 0, you know, due to fixed time. So here you have to write theta C and delta. So the equation becomes MCD is equal to 1.333 EI theta C minus 0.333 EI delta. Then similarly MDC is equal to MFDC plus 2 EI by L, theta C plus 2 theta D minus 3 delta by 6. So here you put I is equal to 2I and L is equal to 6 and MFDC is equal to 0. So MDC is equal to 0 plus 2E 2I by 6 theta C plus theta D. So theta C you have to keep here and theta D is equal to 0 minus 3 delta by 6. So after simplification, MDC is equal to 0.667 EI theta C minus 0.333 EI delta. So these are the slope deflection equations. Then you have to take the equilibrium equation. Summation of moment at B is equal to 0, that is MBA plus MBC is equal to 0, and put the value of MBA plus MBC in this equation. Then after simplification, so this is the equation 1, 2.333 EI theta B plus 0.667 EI theta C minus 0.375 EI delta is equal to 120. Then the another equation that you get, summation of moment at C is equal to 0. So MCB plus MCD is equal to 0. So put the value of MCB and MCD in this equation. Then after simplification, you get 0.667 EI theta B plus 2.667 EI theta C minus 0.337 EI delta is equal to minus 120. This is equation 2. And the third equation you can find out from the horizontal shear. The third equation will be obtained from the horizontal shear in the vertical member. So this is the vertical member AB and this is the vertical member CD. So from these two vertical member, find out what is the horizontal shear HA and HT. So consider the free body diagram of column as shown in figure and taking moment about the top joint. So you have to take the moment for column AB about the joint B and for column CD about the joint D. In column AB, take the moment about B, so that is MAB plus MBA. Both are clockwise is equal to anti-clockwise moment. MAB plus MBA is equal to HA into 4. That is HA is equal to MAB plus MBA divided by 4. Similarly, here take the moment about D in column CD, and here also both are clockwise MDC MCD. MDC plus MCD is equal to anti-clockwise moment, SD into 6. SD is equal to MCD plus MDC divided by 6. So this is the horizontal shear at support A and support D. Then now considering the horizontal equilibrium of the frame, that is HA plus HD is equal to 0. So here you know HA is equal to MAB plus MBA by 4 and HD is equal to MCD plus MDC by 6. So by putting this in this equation, so here you get the third equation. Then put the value of MAB, MBA, MCD, MDC after simplification. So this is the equation 3. 4.5 EI theta B plus 4 EI theta C minus 3.583 into EI delta is equal to 0. So this is the third equation. So this is first equation, second equation, and here you got the third equation from this equation. Then after simplification of these three equations, so you get EI delta is equal to 23.842, EI theta C is equal to minus 60.127 and EI theta B is equal to 72.414. Then after knowing this value and after putting in the slope deflection equation, so you get the final moment. So the final moment MAB is equal to 27.266 kilonewton meter, MBA is equal to 63.473, MBC is equal to 63.4577, MCB is equal to 88.151 and MCD is equal to minus 88.089. So MDC is equal to minus 48.044 kilonewton meter. So you check at joint B, the sum of the moments should be 0. So here 63.473, 63.577. So you take 63.5 and this is minus 63.5. So the sum is 0. And here also the sum 88.1 and MCD is equal to minus 88.1. So the sum is equal to 0. Then find out what is the free bending moment diagram for span BC. On span BC there is present the uniform distributed load. So find out what is the maximum positive moment at midpoint of BC. This is WL square by 8, 40 into 6 square by 8. So this is equal to 180 kilonewton meter. Then according to the moment MAB, MBA, MBC, MCB, MCD and MDC, so give the direction of the moment. So MAB is equal to 27.266 kilonewton meter positive. So here the direction is clockwise and MBA is equal to 63.500 kilonewton meter. So here positive, here also this is clockwise direction, and MBC minus 63.500 kilonewton meter. So MBC is minus 63.500 kilonewton meter. So here this is anti-clockwise, and MCB is equal to 88.100 kilonewton meter. So this is clockwise, and MCD is equal to minus 88.100 kilonewton meter. So this is anti-clockwise, and MDC is equal to minus 48.044 kilonewton meter. So this is also anti-clockwise. So these are the direction of the moment. Then after giving the direction of the moment, then you can plot the support moment diagram. So here this is inner side. So take inner side 27.266 and this is outer side, take 63.500 kilonewton. This is inner side 27 point, and here also this is inner side. So take this is 48.044 and this is outside, take this is 88.100. Inner side 48.0, outside 88.100 kilonewton. Then join this point, and here also join this point and this point. Inside tension take positive and outside tension tech negative. And here for horizontal member, so this side this is MBC and this side this is MCB. MBC is equal to 63.5 and MCB is equal to 88.1. So this side take 63.5 and this side take 88.1 and join this one, and this is the negative bending moment diagram. Then draw the free bending moment diagram or positive bending moment diagram, parabolic, as the load is present uniform distributed load. So here this is the maximum positive moment on the span BC at the midpoint is equal to 180 kilonewton meter. And then the overlap portion negative positive, this is cancel each other. So here this is negative negative positive, this is negative positive, and here this is also negative positive. And then you can find out what is the maximum positive moment here, because you know here this is 63.5, this is 88.100. So draw one line here and take one ordinate here. So find out by taking the similar triangle, this is one triangle and this is another triangle. So find out the ordinate. So after knowing this ordinate, so this total ordinate becomes this ordinate plus 63.500, and you know the total ordinate, this is 180 minus this ordinate, so that you can find out what is the maximum positive moment here. So this is the complete bending moment diagram of the sway frame. Now all are clear how to find out the moments of the sway frame by slope deflection method, and how to draw the bending moment diagram.